And if we look into this family tree, let's concentrate on Queen Victoria. Now, Queen Victoria had this disease, but phenotypically she was normal, because now we know that the hemophilia is responsible for a defect in a gene which resides on X chromosome. It's a recessive gene. Now, since Queen Victoria was a carrier, she was phenotypically normal, nobody ever realized that she was a source of the disease. Interestingly, she had 9 children. Of the 9 children, one of her son, Leopold, showed the phenotypic expression of the disease. That is, in this disease, what happens? It's a congenital disease marked by slow blood coagulation, and the smallest of bruise often becomes prolonged internal bleeding. So it was a life-threatening disease. Now let us come to, so these were the 9 children. So Queen Victoria had 9 children with Prince Albert. So these were her 9 children. This is Prince Albert, this is Queen Victoria, and these are her 9 children. Princess Victoria, Albert Edward, Princess Alice, Prince Alfred, Princess Helena, Prince Louis, Prince Arthur, Prince Leopold, and Princess Beatrice. Prince Leopold was an affected male, but there was somebody who was also a carrier to this disease. Now let us look back to the princess who was a carrier to this disease. Now, as I said, that since if a male inherits this gene, one of the X chromosome will come from the father. Since Prince Albert was normal, and one of the X bearing that gene will come from the mother, so the female will also be, if a female child gets hold of that gene, the female will also act as a carrier. So now we have 2 females in Queen Victoria's line as hemophilic. They were phenotypically normal, but they were carriers, Princess Alice and Princess Beatrice. But we will concentrate ourselves to Princess Alice. Princess Alice had a daughter named as Alexandra. Alexandra, as you can see, Princess Alice married Louis of Hesse, and they had a daughter Alexandra, who was also a carrier but phenotypically normal. Since the parents were normal and the princess were normal, nobody realized that the princess could be a possible carrier for the hemophilia gene. She was married to the last Tsar of Russia, the last heir of the Romanov dynasty. Russia had been ruled for the last 300 years by the Romanov dynasty. Nicholas II, Tsar of Russia, was the last heir of this Romanov dynasty. And Alexandra was married to Nicholas II, the Tsar of Russia. So she was in fact the last Tsarina. And this couple had 5 children. 4 were girls, and the only male heir to the throne, to the Russian throne, was Alexis, who was again an affected male. So this is how did this, if you can see from the Queen Victoria's tree here, so we can see that her 2 daughters were carriers and her 1 son was affected, and how this hemophilia gene had found its way to a lot of European royal families during that time. Now let me start so this is Princess Alice, and this is Alexandra. We'll come to this story only. We'll restrict ourselves to Alexandra now. So Queen Victoria was Alexandra's grandmother, and Fatefully, Alexandra inherited the gene from her grandmother, who was a carrier, then from her mother, Princess Alice, who also was a carrier, and Alexandra herself was a carrier. And this is Princess Alice, and Alexandra was married to the Tsar Nicholas. As I said, the Romanovs had ruled Russia for 300 years, and Nicholas was the last Tsar of Russia, and Alexandra, or she was known as Alex, later on she was coined as Alexandra when she was married to Nicholas II, and they had these 5 children, of which Alex was a boy who was affected. We do not know if her daughters were carriers or not. It is not known now. Now, since Alex was affected with this deadly disease, what happened is that whenever Alex would suffer from a cold, and if you remember the importance of Alex, he is the sole heir to the Russian throne. So he is the last living representative of the Romanov dynasty. And we are talking about the time around 1905 to 1918. So you can imagine the extent to which medicines were available then, extent to which knowledge of the disease was available then. So we are talking about an era around 1905 to 1918. So the knowledge regarding medicines were low. The knowledge regarding to this disease was also very low. Now, nobody knew what Alex was suffering from. Both the Tsar and the Tsarina tried to hide this from the general public because they wanted to show that the next Tsar or Alex was fine. But Alex used to suffer from bouts of cold and extensive painful joint pains, because whenever there was any sort of internal bleeding, as you realize by the name of the disease, that because of absence of a clotting factor, the blood wouldn't coagulate, and thus blood used to seep into his joints and used to result in extensive pain. So let me show you a picture of Alex, a larger picture of Alex. So this is Alex. And fatefully, unluckily, whatever way we call it, Alexandra met a Russian monk, Grigory Rasputin. I don't know how many of you have heard the name of Rasputin. Grigory Rasputin, who in some way or the other was able to alleviate Alex's pain. In fact, in 1913-14, one such incident happened where the bleeding started and the bleeding couldn't be stopped. The doctors had already said that there was no way to save Alex anymore. This was around 1913-14. There was no way to save Alex anymore. And Rasputin said that no, let the doctors give their statement, don't have to show him to the doctors. Some way, in some mystic way, later on the doctor said that it might be hypnosis or whatsoever, Alexis was saved by Rasputin. And since both the Tsar and the Tsarina became indebted to Rasputin for saving their child's life, Rasputin started taking control of the Russian politics. And the Tsar became isolated from the Russian people. Rasputin started gaining more and more power over the Tsar and the Tsarina. And gradually what happened, people started hating Rasputin. And along with Rasputin, people started hating the Tsarina, because people started saying that Tsarina had some sort of relationship with Rasputin, and people started hating the Tsar itself. So a simple disease in the background, which was hemophilia then, created an uproar in the Russian politics that finally led to the fall of the Romanov dynasty, which ruled Russia for 300 years. So in 1917, Nicholas had to abdicate the throne. he also had to abdicate the throne from Alexei. So the Tsar rule came to an end. In 1918, Rasputin was murdered. In 1918, around April, the whole Tsar family, the whole family of Tsar. So this was Rasputin. This is Rasputin, and you can see Alexei with his father and sister. This is Nicholas Tsar. And as I was saying, in 1918, around April, the whole family was put in front of a firing squad and was brutally killed. I told this story because how a disease, which was not known then, what might be the medicine, what might be the nature of the disease, nobody knew then. And because nobody knew then, because nobody knew the underlying cause of the disease, how a single simple disease of Alexei brought to an end. It was, I wouldn't say that this disease totally brought to the fall of the Tsar. There are other reasons, but this was one of the most important reasons, as a result of which the Tsar rule fell in Russia. And in 1918, as you all know, it was the end of the Tsar rule in Russia. Now, interestingly, in 1991, this is a story. In 1991, a pit was found which contained skeletal remains of 9 families. For the first time, DNA fingerprinting forensic analysis was done to identify the family, and it was found, it was that the Romanov family was found, the Tsar Tsarina and her 3 children's remnants were found, 2 children's remnants were not found. So people started presuming that most probably the youngest daughter of the Tsarina, that is Anastasia. So this is the youngest daughter, Anastasia and Alexei must have somehow escaped that fateful firing squad. When in 1991, only 5 skeletons were found, the Tsar Tsarina and her 3 elder daughters. In 2007, again, another grave was found containing semi-burned human bone fragments. And then Professor Rogev at the University of Massachusetts Medical School extracted the DNA and identified these 2 DNA samples with the earlier 3 DNA samples obtained in 1991. And it was concluded that in 2007, the 2 skeletons that were found belonged to the 13-year-old Alexei and the 19-year-old Maria, not Anastasia, Maria. And they then concluded that the royal disease was Hemophilia B, which was due to a mutation in the F9 gene within the X chromosome. So the Russian Tsar and his family were killed in 1918, and you can assume almost 90 years after, the actual defect could be identified. And thus, this is a story. This was a very interesting story. This story also holds true for DNA forensic analysis, because DNA fingerprinting was then used as a tool to identify whether the skeletal remains were of Tsar, Tsarina, and her 5 children or not. Now coming to hemophilia, the disease that in fact killed, finally brought fall of the Tsar system in Russia was, as I said, hemophilia B, caused due to mutation in the F9 gene, which results in a single nucleotide change in the gene for the cotting factor 9 that causes incorrect RNA splicing. Since you people are aware of the molecular biology, since you people know the basic pathway of central dogma, you can realize that one single nucleotide chain automatically changes the recognition of the splice site and brings about a defect in the RNA splicing, as a result of which there's a defective protein and blood doesn't clot. So that was the story behind hemophilia. And now coming to the disease, As we saw from the story, that Queen Victoria was a carrier. So she was a carrier mother or the grandmother of Alexandra. And F9 gene was the defective gene. As a result of defect in the F9 gene, a single nucleotide change occurred, resulting in a defective RNA, resulting in a defective blood clotting factor. As a result of this defective blood clotting factor, hemophilia occurs. For males, as we know, if there is one defective gene that is inherited, in this case, as you can see, it is inherited to the son is affected, and it can be also inherited to the daughter, but here the daughter is phenotypically normal or carrier. If we have an affected father, then as per the pedigree, all males will be normal because the father is having an affected X chromosome. The X chromosome will move from the father to the daughters of the next generation only. All males will be normal. So an affected male will always have all normal fathers. As you can see here, the affected male will always have all normal fathers. Let me bring the pen. So we are having a carrier state here. This is how it moves, and it is moving to the son. From the son, it is moving to the daughter. As you can see, affected X moves to the daughter. All males are normal, and from the daughter, again, we are seeing an affected male. Because the mother is having two X, one normal and one affected. So there is a chance that 50% of the sons will be affected. So you can see a crisscross pattern of inheritance. Female normal, male affected, female normal carrier, male affected. This is a recessive trait. How do we understand? If you look into this parent, they are phenotypically normal, giving affected children. If we look into this parent, they are phenotypically normal, giving affected children. So the trait is a recessive one, and the trait is X-linked because defined orientation of how this trait is being inherited. It is moving from the carrier normal phenotypically mother to the affected male child, from the affected male child to a normal carrier, phenotypically normal carrier daughter, from the phenotypically normal carrier daughter to the affected son. Define crisscross pattern of inheritance. So this is how X-linked genes move through human population. So with this, we come to the end of this class.